afternoon. It's 2 o'clock. I don't know why I went for morning. Time is just disappears when you're having fun, clearly. This is a bonus live stream for Higher Tier GCSE because my Year 10 class, who are doing higher, are currently doing this week. One of the things they've got to do is stratified sampling. So I thought I'd do a little teach on stratified sampling so that it would help them with their work, and why not share it with the world. So if you're wanting to learn about stratified sampling, it's going to be possibly not be a very long video, just going through a couple of questions, talking about what it is, and just a little bit more information. So what is sampling in general? When we're doing research or investigating something and wanting to get people's opinions, you have to work out who to ask. Because, for example, if I speak about my school has 1,300 people in it, children. If I was doing a survey, asking all 1,300 gets quite big, but you can go bigger. Let's say my I've just said my 9 times. My football team, Watford, they regularly get 22,000 people at their home stadium. You can't ask 22,000 people meaningful information and collect it. So you need to come up with smaller samples of that information that represent everyone. Now, the school is a good example of why we need something called stratified sampling. Because if we just do random sampling, I could just get, let's say, 20 random students. They could all be Year 7s. And that wouldn't be representative of all the students in the school. It wouldn't be fair. Equally, they could all be female. And that wouldn't be representative of all the other genders and of boys and everyone else who's there. So it's very important that you are considering, when selecting your samples, what proportions make up the thing. The problem with this being, how do you decide what criteria to use? Well, that's what we're going to have a quick look at today. If you don't consider these things, you get something called bias. Bias is where some people have more likely for their opinion to count than others, and there are examples of bias throughout life, unfortunately. It is just a thing that you are more likely to go into government and get into politics and be the Prime Minister if you went to a private school or to an Oxford or Cambridge. It just is that, it is that way at the moment. There are bias all over the place. But when we're doing research or surveying, it's quite important that we try and avoid it where possible. So what I'm going to do is I'm going to talk you through just 2 examples of stratified sampling, showing you how it works and explaining why I've done it. Then in the description below the video you will find the worksheets I've taken. I've taken the first and last questions from that worksheet, and those worksheets are available for you to go away and practice more of. And then if you're in my class at school, you'll know that there's more questions online for you to do as well. But this is for everyone. Hello Sandman, hello Fun Pugs. Nice to see you both. So let's go straight into my whiteboard. And hopefully I'm here and I can be on screen as well, just so you can see me in all my smiliness. So it says here, the table shows information about the inhabitants of a village. Bernard is going to carry out a survey about the local library. He wants to find out how often people have been to the library in the last year. He decides to take a stratified sample. So this is the first time we've seen this reference to a stratified sample. Another way of calling this, you could say a representative sample, a sample that represents the data. Explain why it's important. The reason it's important, we would not need to do it if all of these numbers here were the same or similar to each other. The reason it's important that we use a stratified sample is I believe because there are way more 21 to 40-year-olds than over 60s. In fact, there's 3 times as many. And because of that, if we just did it randomly, the over 60s would get more of a chance of being in the random sample, every person is going to be randomly produced. We want our small sample to represent that large population, so we would want more of the people in that small sample to be between 21 and 40 than are over 60s. So in order to do the stratified sampling, we just need to consider one key bit of information. The stratified sample is the fraction times the total. And what that means is the fraction here, we would need first of all a total. Now on my desk I normally have my calculator, and of course just when I need to use it I've gone and put it somewhere safe. You know when you put something somewhere safe and it instantly goes missing whenever you need it? That's exactly what I've done. So my calculator will appear, I'm pretty sure, the minute we are all done here. I can't see it for the life of me. It's probably on the floor somewhere. I've tied it away into a thing of the floor. So fortunately I do have a calculator, but I will just need you to bear with me for 2 seconds. I just have to type in and bring it up. And hopefully that will bring it up on here. And I think I'm even right in saying that I can do this and bring it onto the screen. Maybe not. Let's see if this works. You may well. Oh, you could see that. I thought I'd put myself on the screen. What an idiot I am. So you can see my calculator. Apologies for the unprofessionalness there. We've got, on my calculator, I have got a total of 693 plus 1203 plus 802 plus 405, 3103 people. That means if I want to have a representative sample here, I want to have 693 out of 3,103 multiplied by the total in the sample. And here it says we're doing a sample of 100 people. So it's 693, 3103 multiplied by 100. And so we can again bring up my calculator. We want 693 divided by 3103 times 100. This is what a stratified sample looks like. And it says 22.3. We cannot have 22.3, so we're going to have 22 people in that age group. This is the structure of all of the stratified samples in this data. The population amount, divide by the total, then times it by the size of the sample, because we want that is the fraction basically. This is a fraction multiplied by our sample. So we're going to have a fraction of the sample is going to be this fraction of the sample, and we have to repeat it effectively 3 times, because the last one we can add up and see what's left from 100. 1203 over 3103. Notice the only thing that's changing each time, and 802 over 3103. The total stays the same, the times by 100 stays the same, and we just change which one we're talking about. So I bring back my calculator. 1203 divided by 3103, and change it to it's times by 100, so it'd be 38.8. I'm going to call that 39. And we've got 802 divided by 3103. And this does create a slight bemusing situation. Whereas it is possible, which is 25.8, It is possible by random chance that you could end up with 3 numbers that round up and 1 number that rounds down, and this total can end up being more than 100, and then you just have to make a small adjustment. But what I like to do is not bother doing the last one. I just go, okay, what's 22, 39 and 26 makes 8, 17, 3, 6, 7, 8, 87. That's going to leave 13 people there. That is how we come up with our stratified sample. The key words were stratified sample and sample of 100. Notice how I'm drawing out the information from the question. I was allowed a calculator for this one, and that's going to become relevant in the next question where we're not allowed a calculator. So this one you can see not allowed a calculator, which means the numbers are likely to be nicer. A teacher decides to do a survey. She asks for a stratified sample, and 40 students in year 4 were selected. And what this does, this works backwards, because year 40, year 4 students, that tells us the answer to the year 4 thing, and we don't know the sample size. But we do know, if we find a total, that this is going to be 355 people. And we do know that 100 out of 355 times the sample equals 40. What we can do, therefore, is divide by the fraction. So 40 divided by, let's get rid of the over. Remembering that when we divide by a fraction, we flip it upside down and change it to times. 40 times 355 over 100. And so they will cancel quite severely. So 4 times 355 all over 10, so we divided by 10. We will divide by 5, leaving that as 60 plus 11 is 71. And this is going to divide by 5 to go to 2. Then we'll divide that by 2 and that by 2. So we end up 2 times 71 is 142. The sample has 142. I did that by working backwards from the proportion. I knew the proportion times the sample was 40. So working backwards, I knew it was 142. But the question says, work out the number of year 6 students. So we now have to do a forwards version, which is why I changed colour. I now need to do 135 over 355 times 142. So we've got some cancelling to do again. Fortunately, we know it divides by 5. That made 11 plus 60 is 71. And that divided by 5 is 20, is 5 by 5. Come on, Mr. Harris. 2 and 27. So we've now got 142 and 27. Do they both divide by 3? They don't. We might not have some nice numbers to deal with here. They don't divide by 7. So we're going to need to do 27 times 142. An odd question to do without a calculator. And that leaves us with no cancelling out at all. Oh, 71 and 142 cancel out. That, I was looking for something like that, so the answer is 54. Because they've got numbers that cancel out. Obviously with a calculator it's much, much easier, but this is just showing you can do this with a calculator. So, Sandman, I work it out by using the SSF and then dividing each column by the SSF in this case. Okay, so that's the sort of the stratified sample factor. So it's working out how many times the sample goes into the total, right? So what he's saying is, another way of looking at it is the SSF is, because it's going to be easier if I go back to the other question. he's looking at this and going, SSF, another way of doing this, especially with the calculator, is if we know that there's 3,103 in the total, if we divide that by how many there are in here, the sample, we can see how many of them there are in the sample. So we divide it by that, so we get 31.03. What you can then do is, well, if we know that this is 31 times smaller, we can take each of these numbers and divide them by 31.03. It's another way, another valid way. And the good thing about maths is that there's often more than one way to do a thing. So if you like this one, it's another way of saying, well, that's the sample, that's the total. This must be like the factor, that the number of them you need. So if we divide by that, we can see how many will go into the sample. That's an absolutely valid way of doing it. Oh, it's Sam. It's Sam. So clearly, that's the way you do it. That's absolutely fine, Sam. And either of those ways are perfectly valid. So, thank you very much. Hope this has been useful, either whether you joined me live, the 4 or 5 of you who joined me live, or whether you come back and watch it later. This has been some stratified sampling. Hopefully it's introduced a bit about bias, a bit about how stratified sampling works. Use the description below to find out where to do some more questions. I've been Mr. Harris. You haven't. I hope you have a great day, and I will speak to you soon.